Hi, I'm Jenna Likens from Red Hat, and I wanted to introduce to you the Co.Lab Robot. And Red Hat developed this in partnership with SparkFun. It's an amazing robot. It's got so many capabilities. The two big parts of its brain are the microbit up here and the motobit down here. The microbit, which can be taken out and used for all kinds of interesting stuff by itself, has an array of 25 LEDs, a whole row of pins, which are covered at the moment because they're inserted into the motobit, that you can use to connect things to the microbit. It's got two programmable buttons, an A button and a B button, so you can tell it to do things when you push buttons. It's got a temperature sensor, it's got a motion sensor, and it has a compass, so it can tell you that it's moving and what direction it's moving. It also has a light sensor, but we have our own light sensors. And they're right here mounted on the bottom of the bot. And these are 3 IR light sensors, and they emit infrared light, and then based on the light that's reflected back to them, they can tell light from dark. So you can use these 3 sensors to do things like follow a line. And we're going to use these in an exercise later on. Today we are going to get this bot built and get it running. The bot also has a top chassis and a bottom chassis and all the pieces you need to connect those two. The motobit, and this is the part of the brains that knows how to control the motor, so it's very important. You've got 2 DC motors, and they're in here in between the 2 chassis, sort of tricky to see, but there they are. And you also have 2 wheels, which we're gonna call wheels, but actually it's a wheel, which is the center portion, and the tire, which is the outer portion. In this case, you can't change the tire, it's attached to the wheel. So, the rest of this video is gonna be tips and tricks that I figured out when I was putting this together, things that I found useful and that I hope you'll find useful when you're putting yours together. And I hope you enjoy your robot. It's kind of amazing and super fun to play with. And once we have her built, got lots of great things to do in upcoming activities, so make sure to stay tuned. Okay, these are the 2 pieces of the robot chassis, and what we need to do is remove some of these pieces that are attached. So just do it carefully, don't use pliers or anything, and they should pop right out. So 2 of those, 2 of these, and one of that, which looks like a little mushroom. And then these last 2 pieces, just be gentle when you're pulling them out because they're a little bit more delicate. I give it a little twist, so push on the front of one side and the back of the other. You can see it from the side. If you rotate it like that, that'll make it snap right out. Okay, so that's all the pieces removed from the 2 chassis. 2 chassis pieces, a top and a bottom. They look a lot alike. They're not though. So in order to make it easier for myself as I start to assemble my robot, I like to make marks on them so I can easily tell which is the top and which is the bottom and what direction they should be pointing in. Here's what I do. First, I take the top chassis piece. Top chassis piece is the one that has these 2 rectangles and these 2 ovals. Then I want to find the top surface of the top chassis piece. Each of your pieces has a textured side and a smooth side. The textured side is going to be the top. So then I want to find the front, and the front is the side where the rectangle has these two little extra dots on it. The back does not have those dots. And when I say front, I mean if your robot were driving along, that would be its front end. And then finally, I want to find the left corner of the front of the top chassis on the top side. So this is the corner I'm talking about. And I like to mark it. And you can use whatever you want. I always have electrical tape handy. So I take two little pieces of electrical tape and make myself a little L, like that. Then for the bottom chassis, I do something really similar. So I'm looking at the textured side on top here. So this is the top of the bottom chassis. Then I want to find the front of the bottom chassis. The front is the one with the big rectangle cutout. And then again, I want to find the left side of the bottom chassis. And I have a different kind of tape, and I just put a little mark. I don't make an L. I just mark it like that. The neat thing is that then when I've done this, it's really easy to tell my top from my bottom, and I know that if I have my marks aligned, and you can see there that my L will be on top of my candy cane stripe tape, then I've got my chassis assembled correctly. So, little hint, use whatever you want. I use electrical tape or tape. You can use stickers. I've used a paint pen in the past. Up to you. Just make it easy on yourself by marking your front left corner of each piece so you can tell them apart. Adding the rear motor mount, which we have two of, to the motor is, to me, one of the hardest things about the project because it seems impossible. Here's my trick. I take a short length of electrical tape, and this is maybe 1.5 inches long, and I cut it in half, so it's only that wide. And wrap it over the two wires. That'll keep them in place so they're not slipping, and it'll also protect them a little bit, which is good because you don't want to nick them or damage them if you can. So here's what I have to do. I use my channel lock pliers, and you're gonna get this kind of set on top, and then push with your channel lock pliers and wiggle that little mount into place. And that worked. And once it's on there, you'll see that there's a little cutout where the wires go through, that they're protected, and it'll fit nicely all the way around the bottom. So do that for both of your motors. I'm going to end up routing one of the bundles of cable through the same hole as another bundle of cable, and I don't want to get them mixed up. So what I'm going to do is mark one of them so I can keep it straight. And the one that I'm going to route in the same place as another one is this center bundle for the line sensor. So the way I mark it is with a tiny piece of electrical tape, and I just wrap it around the connector. That's all it takes, so that when these two come through the same hole on the top side of the chassis, it'll be obvious which one is the left sensor and which one is the right sensor. I'm putting in the nub caster, which, yes, that's a ridiculous name. And so I'm on the bottom side of my bottom chassis, and I'm going to put it in this front slot here. And what I do is I brace behind the place where I'm putting the slot, or putting the piece rather. And then, so I'm braced behind the slot. I have my nub caster in the slot, and then push straight, and you also kind of have to rock a little bit sometimes to get it in. And this is the part I'm talking about. It takes, there it is, a little bit more force than you might think. So as long as you're pushing straight and not at an angle, you won't break it. So don't get discouraged and think it doesn't fit. Just give it a little bit of extra oomph, and then it'll go. I'm in the process of attaching the top chassis to the bottom chassis, and I've done the 3 of the corners and 1 of the motor mounts, and I'm getting ready to do the last motor mount, the second motor mount. And the first thing I have to do is check and make sure that the tabs are actually aligned with the slots, because of course, you know, things shift when you're moving them around. Once I know they're aligned, gotta give it a really good squeeze to get it to pop into place. There. And now I have 1 corner left to do, and again, first step, check and make sure those tabs are aligned with the slot, and secondly, give it a good solid squeeze. Okay, top chassis attached to bottom chassis, and I've routed the left line sensor, which is the one that does not have the tape, and the center line sensor, the middle one, which does have the identifying tape, through this leftmost oval, and along with the left motor wires. And the right oval only has the right sensor going through it, and the 2 wires from the right motor. So we're good to go on that. If you look from the side, the robot has these pincher claws, and the pincher claws are what ends up holding the motor bit. And the motor bit has these cutouts that you can see here and here that the second part of the pinchers fit into. So I've had the most luck inserting the combo this way. So I put the motor bit down in not the very last set of notches, but kind of the second to last set of notches. And then you're going to push down on the other side of the micro bit, and hopefully it'll snap in flat. Now, mine isn't. So what I have to do is relieve some of this tension, and by pulling these little guys apart a little, I can get it to snap down horizontally, and that's what's happened. Okay, so I have got the software downloaded onto the microbot, and I am going to push button A and see what happens. And what happens is that I have a fantastic example of spinny robot syndrome, which means that one of the 2 motors is a reverse wired motor. So what I'm going to do to figure that out is go into the software and change one of the settings, either right or left, and see whether that fixes it. and I'll be right back. Okay, so the original code has the invert set for both motors to false, and that gave me spinny robot. So what I've done is I've just gone into the code and reset the left motor, chosen at random, to true instead of false. When I push button A, one of two things should happen. Either robot will drive forwards, in which case I randomly chose the right motor to change the invert on, or robot will drive backwards, in which case I guessed wrong. Let's see which happens. Oh! So that was backwards robot, and that means I randomly guessed wrong. So now I'm going to go try again, and this time I'm going to switch the left invert back to false and switch the right invert to true and see if that gets me forward going robot. Okay, so I've just gone back into the code and switched the left motor invert to false and switched the right motor invert to true. Everything goes correctly. This time when I press the A button, robot will go forwards. Let's see what happens. Okay, I win. So it turns out that the right motor is the one that's reverse wired. So now that I know that, I can make the change on the hardware side and change the code back in the software to what it was originally. So I'm going to retrieve that robot and show you what I mean. So here we go. So since I know it's the right motor that's backwards, all I'm going to do is pull the right motor wires out, and I'm going to do opposite what the instructions say. So the instructions, or the silkscreen, wants me to put black on the bottom and red on the top, and I'm going to reverse that and put the black on the top and the red on the bottom. Now, before I run it again, I've got to remember to go back and change it back to false and false, which are the defaults in the software, and re-download my code. So I'm going to do that, and then we'll test it one more time. Okay, quick recap. I hooked the robot up, downloaded the sample code, push button A, and got spinny robot. I randomly guessed that it might be motor left that was wrong, so I changed the invert on the left motor to true instead of false, tested it, and that got me backwards robot. So then I knew it was the right motor that in fact was backwards, was reverse wired. So I switched the right motor in the software to true instead of false, switched the left one back to false, ran that, and that got me forward going robot. So then I have now made the change at the hardware level. And that's sometimes a better thing to do because it means you've got less variables going on in your code that might go wrong. So what I've done is on the right motor, since I knew that was the one that was backwards, I switched the red and the black so that they're opposite what the silkscreen says they should be. Now, and then I had to go back and change my code so that both inverts were set to false in my code. So with that, hopefully we're going to have a forward-going, fixed at the hardware level robot. Let's find out. I do. So that's it. That's how you troubleshoot issues with the spinniness of the motors.